Hello students. Today we are going to learn CBSe grade 10 the first chapter, the first topic, which is Euclid's division lemma. Welcome to my channel. Here I used to provide you quality videos on the CBSe ICSE boards. Today we're going to start with the Euclid's division lemma. Maybe it sounds like something interesting, and maybe it sounds like this is something new which you're going to learn. It's gonna be tough. Most of the students used to think that that's gonna be tough. Actually, no. We have learned this division lemma long back, long back ago. So, like in the grade six and the grade seven, when actually we have learned the division. At the moment we have learned the division, we actually have learned the Euclid division lemma. Okay. So here we will be first doing an practical example. As I told you, we have done that before. Right now we are doing it technically, but before that in the junior grade we have did it, but nobody had told us that this is actually division lemma, Euclid division lemma, and you should do this thing. But we have done it. So right now what we are doing, the same thing we are doing in the next example, which I will be doing, proving that. So we are doing the same thing, but theoretically. So let's see. Let's take a number, say 117, 117, and let's divide it by any number, say 2, for example. So it's a simple division. So 5 times 10, 17, 6 times 6, 8 times 16, carry 1. So this is the quotient. We are naming it as Q. This is the remainder. We are naming it as R. And you know that remainder cannot be more than 2 here. So the 117 can be written as 2 into 58 plus 1. 2 into the divisor into the quotient plus the remainder. Now if you compare the given number A as 117, the B as 2, because that's what we know, we are dividing it by 2, so it's B, and we got two different unique whole numbers, that is Q and R. So 58 is the quotient Q, so let's write Q, and the 1 is the remainder R. That means, and we know the R cannot be more than 2, as I told you. So it, as we are dividing it by 2, it can minimum can be 0. If it has the 0 remainder, that means it's perfectly divisible by 2, which is not in this case, and 1. So this is what the theorem says, that A equals to BQ plus R. A equals to BQ plus R. Okay, isn't that easy? We have learned it in junior grade, and that's easy. We are familiar with this thing. So let's do the questions, because in CBSE we have the questions related to Euclid division lemma. Now if you ask me why we are learning this concept in grade 10 under real number in such a senior grade, first of all we should know it theoretically. We know how it works in practically, but we don't know its actually theoretical division lemma, and we can use it in so many practical ways. Okay, so in grade 10 in CBSE we have lot of questions related to that. At least one you should have in exam, and it has a lot of varieties also. Okay, so that's why we should practice it, and it's not very difficult. So let's take a question. The question is, show that every positive odd integer of the form 4q plus 1 or 4q plus 3 for some integer q. We have to prove any odd integer can be represented in the form 4q plus 1 and 4q plus 3, not any other form. So we can prove it using Euclid's division lemma. So let's keep in our mind that what is the statement is, which is a equals to bq plus r, and where 0 less than r less than a. So the answer is, let a be a odd positive integer as it is given. So a be the odd positive integer. On dividing a by 4. Why 4? Because look, we are dividing, if you look at the forms, it's actually bq plus r. The known b is known. If you look at the Euclid statements, the a and b is known. So we have taken a, now it's terms for b. So b is 3, which is both the cases it's same, because we should always divide it with the same number for this case. So a is my 4. That's very important, that you should be able to identify the b. So on dividing by 4, let q be the quotient and r be the remainder. Okay. Now using Euclid's algorithm, using Euclid's algorithm, we can write by Euclid's algorithm, we have, okay, what we have a, this a is equals to 4q 4q, the quotient, plus the remainder r, where, that's very important, where 0 less than equals to 0 less than equals to 4 less than 0 less than r less than 4, because the remainder cannot be less than the divisor. Okay, so what are the possible values of r we can have? The possible values of r will be 0, 1, 2 and 3, because it's between 0 to 4, cannot be equals to 4. So 0, 1, 2, 3. And what happens, we have to write down all the possible value of a using the this 4 type of remainder. So the a can be 4q plus 0, which is equals to 4q. A can be 4q plus 1. A can be 4q plus 2. We can take out 2. It will be 2 into 2q. 2 into 2q plus 1. And a can be 4q plus 3. These are the possible values of a. Now look, it's very much obvious that 4q and this 2q plus 1, both of them are multiple of 2. So these are even numbers, right? These are even numbers. But what we want in the question, we want the odd numbers. And 4q plus 1, because that's a even number plus an odd number, we know that's always odd, so it's gonna be odd and this is gonna be odd. So that means if you divide it by 4, we will be having only two form of odd numbers. One is 4q plus 1, another one is 4q plus 3, and we also will be having two form of even number, that is 4q and 2 into 2q plus 1. So a is odd. When a is odd, it will be in the form, it will be in the form 4q plus 1, a equals to 4q plus 1, or 4q plus 3. Okay, so hope you have understood the video, understood the concept. As I told you, we will always will be having a questions from this Euclid's division lemma. So this is the statement given, We always have to follow the same format while solving this question. So we have to take that a, which is given, which is equals to 4q plus r. Remember that you should always able to write this, and the most important part is the remainder part. That remainder is less than equals to 0 less than r less than 4, because that's what is giving us the possible values of r. Even in the statements also it's given, it must be 0 less than r less than b. Now we just need to, using the possible values of r, we have to write down the values of a, which is 4q plus 0, 4q plus 1, 4q plus 2, and 4q plus 3. In between them, the 4q plus 0 and 4q plus 2 are even. If they are asking for even, you have to write down that only 4q and 4q plus 2. And for the other two cases, 4q plus 1, 4q plus 3 will be odd, because it's an even number plus an odd number, which is always odd. And then we just need to write down the conclusive statement, or you can say in other words the answer, that thus the when a is odd, it will be in the form a equals to 4q plus 1 and 4q plus 3. Okay, so thank you for watching the video. If you have any doubt or any other questions that you want to ask me, you can always ask me that. Thanks for tolerating me, obviously. mm, mm, Keep tolerating for the next couple of years. Because I will be uploading such videos frequently. If you have any other any particular doubt need to be solved, I also provide the one-to-one session. You can comment that onto the section, in the comment section. And keep watching the videos, keep sharing, like, and subscribing me, so I will get to know how many regular students I have. Right now I have 111 regular students. So that's it. Thank you.